back to its original geometry. And so that's what we mean there. We could certainly get a puncture or penetration. So if we've got a relatively, say, sharp impacting object, we may actually go through it. That can either be ductile or brittle. And then we have brittle fracture. So if something happens in a relatively fast period of time, like all of these relatively rapid impacts, and then we get a brittle cracking to occur, actually cracking and failure to occur, classic failure, and that would certainly be brittle. That's predominantly what we're going to be talking about as we move ahead, is the brittle mechanism. Certainly, that's the thing that people think about when they think about impact and its effect on plastics, would be getting brittle fracture to occur. As we head down that way, we're going to start to talk about and compare to and gain an understanding of mechanical overload model. We need to understand that really before we can start to move on to impact. So standard overload. During a ductile overload mechanism, there is no change in molecular weight. There is no breaking of bonds. No carbon-carbon or backbone bonds are broken. The mechanical stresses simply overcome intermolecular forces like hydrogen bonding and van der Waals forces, which results in polymer chains slipping past one another. Basically, it's a disentanglement mechanism. That's how plastic materials break. And to illustrate that, we've got basically a representation of a tensile curve. We've got our tensile bar here, and then we've got a molecular structure there. And we're going to walk through this, and we're going to see what happens on a molecular level and on a macro level to the tensile bar. This is a semi-crystalline material, so we've got very orderly crystalline sections, something like polyethylene or nylon. But in the middle there, we've got an amorphous region, because even the most crystalline materials will have a significant amount of amorphous content in them. And so those are called pi molecules within a semi-crystalline material. So as we start our tensile test, we're going to first go through the linear elastic deformation and then nonlinear elastic deformation.